So thank you very much. Welcome to our talk, Down the RabbitMQ-hole, a hot fix spells lunchtime disaster. My name is Benjamin Shaw. I'm a software engineer here at Urban Jungle, and I've been working here for the last 3.5 years. To the right-hand side of the title slide, you will see a dramatic recreation of my lunch that day with the one solitary bite taken out of it. Unfortunately, when I left the office that evening, that is how it remained. First things first, I'll give you a quick introduction as to who we actually are. Yes, we are Urban Jungle, and here is the hero image that you will find on our homepage, and it pretty much encapsulates what we are about. There's things that we don't like, and many other people don't like about the insurance industry, so we're trying to make it better. So we're an insurtech startup based here in South London, and our aim is to change the industry for good. Embracing technology is a key pillar of our strategy. Many of the incumbents in the insurance industry have been rather reluctant to take up technology and still rely on heavily manual processes. I'm talking about call centers with many people working within them and manual processes to do things such as make a claim or make amendments to your policy. It's our aim to build products that are fair and simple to our customers and reflect the times that we live in. A lot of people now are renting and are renting for longer. You also have young professionals and students who are living with 4 or 5 flatmates in inner cities. And our CEO, Jimmy Williams, actually had trouble a number of years ago trying to insure himself. It was actually such a torrid experience that inspired him to start up a company with the aim of trying to rectify that. As for the actual technology that Urban Jungle make use of, so we have a microservice-based event-driven architecture, and our microservices are written in Python. These services are able to communicate with one another using the RabbitMQ message bus using a publish-subscribe pattern. Now, microservices and pub/sub are terms that are often bandied about by many tech companies nowadays, but what do they actually mean? One analogy that you could use is when you want to go consume news. Ideally, you're only going to be reading articles that are of interest to you. So, for example, you might be interested in tech stories, but less so about stories regarding the Kardashians. Maybe vice versa. Ideally, when you go to your phone, using whatever app you use to consume the news, you're only presented with information that is of interest to you. So with that in mind, a microservice will consume a message related to some topic. It will take that message, it will perform some action associated with it, and then if necessary, it can send a response to the service that requested it. A microservice will also have only one domain and will act on that domain very well. That domain might be something as simple as generating a PDF document, processing a payment, or sticking something in a database. If there is one message that people can take away from this talk, we hope that it is this. If you're going to make a change to a critical piece of your back-end infrastructure, make sure that you comprehend the complete ramifications of the change that you're going to be making. So why is that the message we're bringing to you today? Well, let me talk about that fateful day a couple of months ago. So unfortunately, the morning began with a complete outage of our data store service. It's not an ideal way to wake up, but as engineers, that's unfortunately something you just have to live with. So what was the culprit? Why did we have this complete outage of our data store service? The root cause was a database query was taking a very long time to process. It was taking such a long time that RabbitMQ was actually thinking, oh, I've not heard back from the service in a very long time. It must have died. Okay, what I'll do is I'll take that message and I'll pass it to the next instance of the data store service. However, the underlying query was still taking a long amount of time. So one by one, these consumers went down. None of them could complete the query in time. RabbitMQ assumed that it was dead, and we were left with 0 consumers for our primary data store service. The reason that query was taking so long is that the table that was being queried was entirely unindexed. We simply forgotten to create those indexes when we first put the table into the database. Initially, we were able to get away with it because we could afford to simply scan the table row by row, looking for a particular ID. The way that indexing circumvents this long lookup issue is that it will represent a column as a binary tree, which is a much faster operation to find a particular node, a node that represents some row in the database with a particular ID, rather than scanning it row by row looking for the ID. So to sort this issue, what we do is we decide to add indexes to the table, But we also found ourselves rather unsatisfied with the fact that because the query was taking so long, it caused the instance of the data store service to go down. Ideally, what it would do is it would just take that message and it would take however long it needed to process it and then return that response. So we released a hotfix, and this hotfix had a core library change that could accommodate these longer running queries rather than simply dying when it was taking such a long amount of time to respond to that query. It would just take as much time as it needs and pass back the response. That one consumer would be taken up for a longer amount of time, but it was better than causing a cascading failure with no consumers left. Problem solved. Thank you for coming to the talk. No, I'm afraid that is not the end of the story. A couple of colleagues and I had actually gone to lunch thinking that everything was fine and dandy once again. Problem solved. The first bite is yet to go down. I had a sandwich in my hands. I'd taken the first bite when one of the engineers runs through the door into the lunchroom and says the words that engineers around the world fear to hear. We have an outage. Sadly, I had to take that sandwich, stick it back down on my desk, and had to go investigate why do we have the outage, what was going on. So what we were seeing was slow responses from the data store service, and it was starting to actually cause outages elsewhere in the stack. Upon further investigation, we actually found that it was originating from our customer relationship management system. We were trying to find out how many people had been referred by a particular customer. Given that this wasn't actually a public-facing change, it was only seen by staff within Urban Jungle, we were happy to temporarily disable that feature, and we found the offending message coming from the bus, and we just took it off whilst we investigated a longer-term fix. Having nerfed that feature, something still wasn't quite right. We were seeing elevated CPU utilization on our API servers. Going onto the website itself, things were just a bit sluggish. It was eerily reminiscent of an Ozzy Osbourne interview in the mid-noughties. It looked like Ozzy, it walked like Ozzy, but when he spoke, the words just didn't come out. Something wasn't quite right. So we continued to investigate. We went down a few rabbit holes, chased a few red herrings, a lot of theories we investigated, trying to figure out what actually happened. Thankfully, a little while later, gotcha. We had found out what was happening. What was going wrong? That hotfix we had released that morning turned out to be not so hot. Rolling back that release, we saw that the performance regression dissipated. That brought to a close the events of that day. We could actually go home knowing that the website was performing as we had expected. Everything's great, but unfortunately, we still had to carry out the postmortem. Why did it go so badly? So, that core library change that we released that morning that allowed for these longer running queries, it had actually been initially developed a year prior, but with an entirely different service in mind. It was a different context, a different use case. That service had one simple requirement. We wanted it to be able to consume messages that could take a long time to finish processing. We just wanted it to be reliable. It could take these messages off from the bus, take however long it needed to finish processing it, and then when it was done, it could tell RabbitMQ, hey, look, I'm finished processing that. Give me the next one, and on and on. We just wanted it to be stable. Initially, that core library, it just used a single thread to take the message from RabbitMQ and then pass it to the appropriate function within that microservice. When it was finished processing, it would then go back to RabbitMQ and say, okay, I'm finished processing, here's a response if applicable, give me the next one. And that all happened on the same thread. That core library change that we developed a year prior, it would use that original thread to take the message, but then it would spawn another thread. Using this new thread that is just created, it would pass that message onto the appropriate function within the microservice. Whilst that was away processing, taking however long it would needed, the original thread would be sending heartbeats to the bus. Apologise if I caused any traumatic flashbacks of anyone who had to deal with the Heartbleed OpenSSL bug a few years back. RabbitMQ needs these heartbeats to know that whichever consuming service is still alive. If it doesn't hear back from it within a particular window of time, it assumes that it has died, and then it'll pass it to the next instance of that microservice. And that's what caused the outage that very same morning, with the primary data store service going completely out. So with that release that we did that morning, we had solved the issue of the data store service dying with these longer running queries, but we'd introduced a massive trade-off. To understand that trade-off, we need to look at something called a consumption profile. What is a consumption profile? Well, we have some handy graphs here for you to try and make some sense of it. Please note, these are not to scale and are for illustrative purposes only. So on the left-hand side, we have the other service. This is the original service that we developed that library change for a year prior. On the right-hand side, in the wineglass shape, is what we have is the queue that RabbitMQ is using to pass messages to a service. Inside that queue is a little blue line. That represents a message, and the length of the line corresponds with the amount of time it will take to process that message. On the left-hand side, we have two orange Pac-Men. These are the actual microservice instances that are consuming these messages from the queue. They will take the message, which are quite long in these cases, however long it needs, it'll finish it, and then it'll ask RabbitMQ, okay, give me the next message. Let's contrast that with our primary data store service. So, given that the primary data store is such a critical piece of our backend infrastructure, it's going to be handling lots and lots of requests throughout the day. So we have more consumers represented by the 10 Pac-Men, and then we've also got lots of little jobs that are much shorter than the jobs that we see on the left-hand side. This is because when somebody comes onto our website, they might need to fetch a bit of information from our database to show them a price, for example, or we might need to insert information to our database. This is where that person lives, this is their name, so on and so forth. On the left-hand side is this other service, and like I said earlier, it was designed to just be stable with long-running jobs. Ultimately, in a day, it would only really handle about 80 messages in that given day, whereas the primary data store, we could come to expect a throughput of 20, 30, 40 messages per second. So what happened with this hotfix? How did that consumption profile change for the primary data store service when rolling out that core library change? This is what we had done to it. So the actual processing time, the time it was taking to query the database, that was still taking the same amount of time, which is why the little blue bars are of the same length. However, you will note we now have a red dotted line. What does this signify? What we had inadvertently done was we'd introduced a 1 second floor for our data store responding to some requests. This was particularly bad if some other service needed bits of information from the database to complete whichever job it was running through. Let's say it has 8 bits of data that it needs to get from the database, and it requests these in sequence. Each of the requests would typically take 10 milliseconds to process and get a response back. So 8 by 10 milliseconds, that's 80 milliseconds to get all the information required from the data store. However, with this 1 second floor, that 80 milliseconds became 8 seconds, quite a gargantuan difference. So we were seeing much slower performance, and it was actually proving to be fatal sometimes for other services within the stack. So this is why we simply rolled back the release of that core library change. By doing that, we eliminated the 1 second floor represented by the red dotted lines, and we also solved the initial issue, which was the unindexed table. That query was now passing successfully, but the optimization of saying handle longer running queries had introduced this bad side effect. So that's why rolling it back fixed our issue. So what did we learn on that day? First of all, when you're creating new tables in your database, remember to add your indexes. If we'd done that in the first place, we would have sidestepped the trials and tribulations of that day entirely. We were able to get away with it for a fair while because the table was sufficiently short enough to be able to scan it row by row and still get by. But we eventually reached a tipping point, and that's what caused the complete outage of the data store service on that morning. Second of all, stagger releases of direct fixes and optimizations. The direct fix for that problem was adding indexes to the table. However, the optimization was adding this new feature, adding in this core library change that would allow for longer running queries. What we should have done was added the indexes to the table and then given it a few hours. We would have noted that adding the indexes actually allowed that query to pass. And then, having a few hours having gone by, we released optimization. We released optimization, and then we start to know, like, hey, why is it so slow when I go into a website to log into my account? There would have been a direct cause and effect, a logical sequitur. By combining the releases, by doing them at pretty much the same time, we muddied the waters. We made it harder for ourselves to find out what was actually going on, and which is why we started chasing all of these theories, which links into my third and final point on our learnings from that day. Our CTO, Greg Smith, has a great saying: look, don't think. What this means is, look at the metrics that you have available to you. Look at your performance monitoring. Oh, why is it suddenly taking so much longer to process these very simple requests when previously it would take milliseconds? Don't think means don't come up with wonderful theories before you've looked. Only think about it when you've exhausted every resource, every statistic that you have available to you. In this particular instance, looking directly at the release log, oh yeah, we did this change this morning, changing a fundamental of the primary data store service. Suddenly, we start seeing these massive performance regressions. That would have led us to the answer much quicker, but we didn't stagger them. We were just kind of all over the place. We were thinking rather than looking, which made our lives difficult, a fair bit more difficult that day than it needed to be. So yeah, I hope you guys enjoyed our walks through going down the RabbitMQ hole, and I hope you've learned a few things along the way.